Okay, so to start, question 1 is, what is most nearly the sample standard deviation for the data set shown? So we have 4, 6, 9, and 9. Now, just to do my due diligence and to ensure that I'm not just showing you how to hit buttons on a calculator, we are going to go through the algorithm just so that we're fairly clear on how that works. But when we do it on the calculator, we're going to find how quick it is. If you're good with it, you probably could have already had the answer in the whole time I've been standing up here talking. Now, I printed off a series of handouts for the FE, and one of them was the components of the manual that are relevant to prop stats. Now, if you look in that section, particularly on the left column on the first page, right around down here, you'll find the formula for the sample standard deviation, and it is as follows. So, all right. So we're going to go through the algorithm just to ensure that this works. So problem 1, all right, we have the data set 4, 6, 9, 9. Now, from the reference manual, page 39, so I'll put page 39 of NCES. That way everybody's following where I'm getting this. Oh, sorry, nope, page 37. Page 37. We get that the sample standard deviation is as follows. So it's the square root of 1 over n minus 1, where n is the number of terms in your data set, times the sum of your variances squared, which I guess actually no, that wouldn't be the right term. It's this variance is essentially your sample standard deviation squared, so I don't want to use that. Okay, now in my opinion, I think the easiest way to go about this, if you want to go through and actually do the process, is to set up a little table. Okay, so we have 4, 6, 9, and 9. Okay, now over here off to the side, how do you compute the average of this data set? I know that might seem like a pretty basic question, but we're in review mode, so maybe I'll sort of do this whole thing. So first off, how many terms do we have? Well, we have 4 terms, right? The sum of those terms is 4 plus 6 plus 9 plus 9, so 4 plus 6 is 10, 18, so that's 28. So therefore, the average is 28 over 4, which is 7, right? Make sense? All right. So my first column, I have my individual measurements. I'm then going to determine the difference from the mean. So if you want, you can say the deviation from the mean, the individual deviations. So the first one, we have 4 minus 7, so that's going to be minus 3. 6 minus 7 minus 1. And then we've got 9 minus 7, which is 2. And then this is 2. Now, it doesn't really matter what direction you do this subtraction because you're going to square it. Okay, so negative 3 squared, that's 9. Negative 1 squared, that's 1, 4, and 4. Summing those up, 9 plus 1 is 10. That makes 18. So to compute the standard deviation, it's just the square root of 18 over 4 minus 1. There's my formula. This entire sum on the right, this is 18. That is 4 minus 1. So 18 over 4 minus 1 is essentially, that's the square root of 6, which comes out to about 2.4. So the answer is B. Okay, now that's if you want to go through and do the algorithm. Okay, if you Now, that's not a lot of work, but that was 4 data points. Imagine if we had 8 data points. It's not a lot more, but it does start to add up. And if you've got something like linear regression that you've got to deal with, yeah, that starts to add up. Okay? So, since you're given the calculator on the exam, use it.
Hey YouTube, thanks for watching. Click below and subscribe.